Welcome to a slow, beginner-friendly lesson on try and accept in Python, made for absolute beginners. Catch and continue. Last lesson we learned to read exceptions calmly. Today we learn to do something about them. We meet the two keywords that let Python recover from a problem instead of stopping, try and accept. We write a try block around risky code, an accept block that runs only if the risk becomes real, and we learn the colon and indent pattern you already know from functions and if. We also learn why catching a specific exception like value error is almost always better than catching every error at once. Plan A and Plan B. Here is the project we will work inside. A folder called try_accept_basics. Inside lives pyproject.toml. Under src, a folder with the same name, holding main.py, where we write our Python. A tests folder holds test files for later. This same shape repeats in every lesson from here on, so once you know it, you know where everything lives. The standard shape. Create the project yourself with uv-init try_accept_basics. Move into the folder with cd. For this lesson we do not need any extra runtime libraries, but we add pytest as a development dependency with --dev. uv writes everything into pyproject.toml and creates a locked virtual environment automatically. One command, one project, ready to code. One command. To run the project, edit src/try_accept_basics/main.py. Save it, then in the terminal type uv run python-m try_accept_basics.main. The -m flag runs the module as a script. uv run takes care of the virtual environment. To run tests later, type uv run pytest. This edit, save, run loop is the heartbeat of everyday Python. Edit, save, run. You can put a shield in front of risky code. Python tries. If it fails, you decide what happens next. Shield your code. Recap from last lesson. When an exception is raised and you do nothing, Python prints a traceback and stops. We learned to read that traceback calmly, type, message, line, bottom up. Today we take the next step. Instead of letting the exception stop the program, we catch it. We tell Python, try this risky line, and if it fails, here is what to do instead. The program keeps running. The user never sees a crash. From reading to handling, the try block marks code that might fail. You write the word try, a colon, and then an indented body, exactly the colon and indent pattern you already know from functions and if. Python runs the body line by line. If everything works, the try block finishes normally and the accept block is skipped. If a line inside raises an exception, Python stops right there and jumps to the accept block. Two paths, decided by what happens at runtime. Mark the risk. Here is the shape. The word try, a colon, then an indented body with two lines. We try to read user input, convert it to int, and print it. If the user types hello, int raises value error, and the print inside try never runs. Python jumps straight to the accept block and runs print of that was not a number. The program keeps going. No traceback. No crash. Just our message. Colon and indent. The accept block is your plan B. You write the word accept, optionally the exception type you want to catch, a colon, and an indented body. Here we divide 10 by count. If count is 0, Python would normally raise 0 division error and stop. But because we wrote accept 0 division error colon, Python jumps into our accept body instead. We set result to 0 and print a calm message. We chose what happens. That is the whole idea. Plan B, accept is a net. It catches a specific kind of failure so your program keeps moving. Catch what you expect. Here is the mental model. Python walks into the try block and runs it line by line. If no exception happens, the accept block is skipped completely. Python continues after the whole try and accept. If an exception does happen, Python stops the try block at that exact line, jumps down to the accept block, and runs it instead. Then Python continues after the try and accept. Two paths. One when all goes well, one when something fails. You write both. Two paths. A real example. We read the user's age as text, then convert it to int. If they type 25, conversion works, we print next year you will be 26. If they typed hello, int raises value error, the print inside try is skipped, and we land in the accept body, please type a whole number. Then the program keeps running, and the final print confirms it. The user never sees a crash. We handled the problem. Real input safely. Notice the shape. Try colon, indented body. Accept colon, indented body. This is the same colon and indent pattern you already know from def for functions, if for conditions, and for loops. Every block in Python ends with a colon, and the body is indented one level, usually 4 spaces. To leave the block, you unindent back to the outer level. If you forget the colon, or forget to indent, Python will tell you with a syntax error before any line runs. A pattern you know. You can write a bare except, just the word except with no type. That catches every exception, including ones you did not expect. That is risky. You might hide real bugs. The better habit is to name the exception you actually anticipate, except value error, or except zero division error. That way only the failure you planned for is caught, everything else still surfaces as a real error. Specific except blocks make your intent clear to anyone reading the code, including future you. Specific beats bare, catch specific types, not everything. The right key fits the right lock. Right key, right lock. Here we catch type error specifically. We try to glue the string age : space to the number 25. That raises type error because you cannot concatenate string and int. Our except type error body fixes it by converting the number to str first. We print the result. Notice we only catch type error. If some other exception happened, it would still surface normally. That is the point of being specific. Specific handler, same pattern, different type. We try to parse the string not a number as an int. That raises value error because the string is not a valid integer literal. Our except value error body sets n to 0 and prints a calm note. We print the result. We chose the fallback. We chose the message. We did not silently swallow the error, we handled it on purpose, and we wrote down what the fallback should be. Specific handler. You can attach more than one except block to a single try. Python checks them in order. If a value error is raised, the first except runs. If a zero division error is raised, the second except runs. Only one except body ever runs, the first one that matches. This lets you give a specific, helpful message for each kind of failure the user might hit. Read the input, try the work, then explain exactly what went wrong. One type per block. Sometimes you want to read the actual message Python attached to the exception. Use the word as to bind it to a name. Here we catch value error as err. Inside the except body, err holds the message Python would have printed, invalid literal for int with base 10 : hello. You can log it, show it to the user, or use it to decide what to do next. The as keyword turns a silent catch into an informed one. Read the message. Important, the except block only runs if an exception was raised. Here we parse the string 42, which works fine. The print inside try runs, parsed 42. The except body is skipped completely. Then the final print runs. If your try succeeds, Python moves past the entire except block as if it was not there. Try is for the risky moment, except is only for the moment things fail. Success skips except. Quick self-check. Can you write a try block with a colon and indented body? Can you attach an except block that catches a specific type like value error? Can you explain why a bare except is risky? Can you confirm that only one except body ever runs, even if you attach several? If any feels shaky, rewatch the matching part. Try and except is the most used error pattern in everyday Python. Say each out loud. In one breath, write try : and an indented body around code that might fail. Write except : optionally with a specific type, and an indented body that runs only if the failure happens. Prefer specific types over bare except. You catch only what you planned for, and real bugs still surface. The program keeps running instead of crashing. You decide what the user sees. 2 keywords, 1 idea. Next lesson we widen the toolbox. You meet more exception types you will see constantly: file not found error when a file is missing, key error when a dict lookup fails, index error when a list position does not exist. You learn to catch several types in one except block using a tuple. And you see real patterns from real code, validate input, retry on failure, default gracefully. The vocabulary grows. More types next. Thanks for learning try and except. Next we meet common exception patterns. Plan B in place.